The owner of this double-door refrigerator says that it is not cooling. So now we are going to check the compressor because we suspect that the compressor may be causing the problem. I will check what issue is present in the compressor, and for that, I am turning the power on. As you can see, it looks like the compressor has started and is working properly. At the moment, the amperage is within the normal range. When we checked it earlier, the compressor was not starting at all and appeared to be internally jammed. Possibly, after moving it, the compressor started running. But we have already checked this unit 1 or 2 times at the customer's place, and it keeps showing the same problem. That's why we are going to replace this compressor. Right now, it is working because it is very cold, but as soon as it warms up, the problem will definitely occur again. Now we have this circuit here, which we installed on the compressor. This circuit is without a heat sink. Usually, if you have worked on these before, you may have seen that there is a plastic cover attached to it. That cover helps transfer heat from the circuit to the plastic, and then from the plastic into the air. So, for example, if there is no silicone applied and it is not properly attached, the IGBTs will overheat, which will reduce the performance of the circuit. Now we will mount it here so the heat can be transferred properly. I'll install it now. We have high temperature silicone that can handle up to 250 degrees. I'll apply it to the IGBTs and fill the holes properly so the heat can move out easily. I've applied the silicone. Now I'll choose where to install it. This spot looks good, so I'll place it here and press it down. After the silicone has fully cured, the heat will dissipate through the silicone into the plastic during operation. This will help maintain proper circuit performance. We will leave it to dry for 8 to 10 hours, then install it on the compressor. The circuit's now fully prepared. You can see that hot glue has been applied inside to secure the circuit in place, along with the silicone we applied earlier. Now we'll make the electrical connections. For the power connection, the line in neutral will be connected at these two marked points. All other parts of the system have been disabled, and the circuit has been configured for direct operation, so the PCB works directly. In addition to this, we will also connect the earthing. Now, looking at the next electrical system, from here, the brown wire is the line, which goes up to the thermostat and also supplies power to the light. The blue wire also goes up, so both the line and neutral are going upward to turn the bulb on. Apart from this, the return line coming back from there is this red wire, which is connected here. Now you can see that we've completed the connections. The red wire, the blue wire, and the earthing wire have all been connected here. We will not connect anything else at this point. The work here is now complete, so I will close this box and install the cover. The cover is now closed and everything here is properly set. Now, on this side, we have the IGBTs, so we are adding additional heat sinks here. We will install them in this position so that the heat can be transferred efficiently. The better the heat transfer, the smoother the system will run, and there will be no issues. As you can see, I have created this much heat sink here. Now I have installed this PCB here. What will happen is that the heat will be transferred to this metal surface. The more heat that shifts to the metal, the more relaxed and stable the PCB will remain.
Right.
Now I will purge the charging line so that we can safely charge the refrigerant without any air. The air has now been removed. Now we will introduce the refrigerant slowly into the system. For gas charging, we can use two methods, vapor charging and liquid charging. For liquid charging, let's look at the cylinder. As you can see, it says this end up for vapor, and below it says this end for liquid. So we slightly invert the cylinder to speed up the process. Keep this in mind. You can see the weight here is 8.770 grams, so now we'll add a small amount of liquid. The system is not taking any more refrigerant, so we'll stop here. The system has now started, and the gauge reading has begun to drop. Now we will wait. After turning the system on, you can see that the current draw was high at first. It started at 0.9 amps and then dropped down and stabilized between 0.3 and 0.1 amps. It should not be drawing such high current here. I have now changed the refrigerant label on this refrigerator so that anyone who works on it in the future can clearly see it. I've written R600a here. Now let me test the unit. During testing, you can see that the freezer temperature is showing minus 20 degrees. Proper cooling has been achieved, and as you can see, the cooling is working very well. But there is one issue here, and I'll explain what's happening. As you can see, ice is forming on the suction pipe. When ice appears on the suction line, it usually means that the refrigerant charge is too high. Even though the current draw is around 0.7 amps, which is actually very good and the system is working well, this condition can still be risky. If the ice continues, it can travel into the suction line, and there is a chance of choking or flooding the compressor. That's why we will slightly reduce the refrigerant charge. Now I will release some refrigerant from the system. Refrigerant must return to the compressor as vapor. If liquid enters the compressor, it can damage the valves, pistons, and even the motor. Now, if we look at this system, it is working perfectly. You can see that there is no ice forming here at all. I've also checked the system on the upper side, and there is no ice there either. The pipe is properly cold, just as it should be. And now, if we check the freezer, you can see that it has reached minus 34.9 degrees. Now, after 15 to 20 minutes, the temperature has reached minus 35 degrees. And if we check inside the refrigerator, you can see that a good amount of ice has formed. So the issue here is with the temperature selector switch, which controls the temperature. It is not switching on and off properly, and that's why this problem is happening. Now let's see how we can fix it. Since the original setting is not working at all, we will arrange a separate solution so that the system can be switched on and off properly. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.